Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Joel Chaiken, his brother. Here we are. We're trying to help you understand how to approach SAT math questions. Today's a good day for me because today is not going well for me right now. I'm just had a very frustrating day. So I'm a little flustered, and so would you be, because in this test, this is the 36th question in the last section. So you've already been doing SAT stuff for 3 hours, and you're hitting this question. So you're in about the same mental state as I'm in. So Seth was gracious enough to allow me to try this problem, given my mental state of not doing too well today. Okay, so let me try this thing. Okay, never saw this question in my life. In the point above, in the figure of, point A is the center of the circle. Line LM.
O is the center.
See what I mean? O is the center. Line, thanks. O, L, M are tangents to the circle at points L. Guess what? I know something. Tangents to a point are equal. Oh, wow. I actually remember that from geometry. If you have two tangents from point, the tangents are equal. And these are right angles, okay? So I'm going to put all these tick marks in even before I start the problem. And these things are radii. They're equal. Okay, now, and the segments L and the segments intersect at point M. Okay, fine. If the circumference of the circle is 96, really? 96. Circumference of the circle is 96. What is the length of minor arc LN? Well, the circumference gives us the radius. So we know the radius. If we need to know the radius, we know the radius. The radius is known because we have the circumference, okay? That's not, we know. So we know the radius. Now, okay, what is the length of minor arc LN? But isn't there a thing, there's a theorem here that says that, it's one of these circle theorems, 60 to, what is it? It's 60.
Should I propose what I think it is?
No, because I have to do what people do on the actual
All right.
test,
I think I know what you'd like to know, but you take it yourself.
I'm pretty sure this is 120. I think that Wait, I remember the theorem.
Yeah.
Lucky me. This is minor arc A. This is big arc B. 60 degrees equals 1/2 the difference of B minus A.
Oh, really?
Yeah.
Wow.
Yeah. Did you know that?
Oh, I could see it, but...
okay, 60 degrees is 1/2. It's 1/2 the difference of the arcs. Now, but we know something pretty cool. B plus A add up to 360. So we're interested in A, right? Wait, let me make sure this is right. We're interested in A. So B is equal to 360 minus A. So 60 is equal to 1/2 360 minus A. Okay, can I write 2A just to save a little time? Which means that 120 is equal to 360 minus 2A. Right? Because I cross-multiplied. Now we're going to subtract 360. I'm in pretty bad mental shape right now from other things. Plus, if you're on question 36, trust me, you're in pretty bad mental shape too, unless you're a genius.
240.
Wait. Don't tell me, Seth. Come on, don't tell me. Minus 240 is equal to minus 2A. Wow, look at that. I was actually right. A is equal to 120. Oh my God, look at that. Okay, so, first of all, do we need to check the answer sheet, or do you agree A is 120?
No, it asks for the length of minor arc.
Oh my God, I would have gotten the question wrong, because this is free form. Oh my God, I would have gotten it wrong.
And A and B are the angles subtended by the arcs.
Okay, so
they are not the arcs.
Let me finish. Okay, so Seth, thank you. In my mental state of not having a great day, I would have put down 120, and I would have gotten the wrong answer. Seth reminded me it's the length. So now I'm going to try to be smart. I'm going to try to be smart. I know that if 120 degrees is a third of a circle, right? I know that, right? Because the circle's 360, right?
Right.
So 120 is a third of the circle. So the answer is actually 130 over 96, which hopefully, well, you have a calculator,
1/3
right?
of 96.
You have a calculator, so the answer is 32.
Yeah.
Oh, okay. Yeah. So I would have gotten this wrong. In my mental state, I would have said, now, Seth, you coming from a point of view of relaxed, right? You did a few things today.
Yeah.
So, don't forget, you're coming in question 36. You're going to be like me on this test. So,
okay.
So anyway, that's how you do it. There may be a faster way to show you that is 120. Maybe Seth will say, oh, yeah, this is 120 because of this. But I had to remember this theorem, that the angle is equal to the difference of called the subtended arcs.
Yeah.
But wow, that was nasty. I would have said, I wonder how many people else would have made that mistake and put one. This is a free-form question. This is not multiple choice.
Yeah.
Oh.
All right.
And it turns out the pi never actually came into the problem. Isn't that interesting? Because if you actually solved for the radius, you would have had a pi. And then it would have been more complicated. So it requires you to know that an angle of 120 is a third of a circle. And the circumference is 96, so it's a third of 96. Okay, Seth, I know you're dying to talk. Go ahead.
Okay. Well, I remembered
Watch
a
out.
fact in geometry.
Watch out.
Let me use red.
Oh, yeah, sure.
So we're different.
Right,
okay.
Good idea.
I remembered a fact in geometry that tells that this angle subtended by two tangents, right,
which angle?
Is half of the angle subtending the same arc from the center. I happen to remember that as a fact from geometry.
Wait, can you put that in red? It's not showing up on the Zyboard.
I didn't draw anything yet.
Okay.
So what I'm saying is, oh no.
You're picking on my radius tick mark. How dare you?
Okay.
How dare you move
what am
my
I doing? I want to draw there we are. This thing. Let's call this.
So that's the central angle.
The central angle, which in your notation was A.
Right.
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 And as a fact that I know in geometry, that A equals 2 times the angle that's here.
Well,
and the angle that's here.
Everybody raise your hand if you remember that theorem. Okay, look, Seth just said this formula, right? But as we were going later in the video, it turns out this is actually not correct. So very short comment. That is not a correct formula. Please watch the rest of the video to see what's going on.
When you have, those angle, like the 60-degree angle, and the angle subtended by the two radii, I mistakenly thought that the angle subtended by the radii is twice the angle subtended by the tangents, and that is false.
Right. False. Do not.
It is. Let me finish. It is false. That is a phony fact. In this problem, because the particular angle 60, it happens to be that the other angle is twice 60. Okay. But in general, the general facts I thought I remembered and applied to this problem is wrong.
Right. Okay, so we're going to stop talking. You just watch the rest of the video, and we will discuss this later in the video. But just remember, do not write that formula down. It is wrong. Okay? Do not write that formula down. Okay, right.
It's 60 degrees.
Let's take a look there. People, raise your hand if you
okay. And so the angle A is 120 degrees.
Oh yeah, you remember that.
Yeah. And now I follow the same logic that Joel did. 120 is 1/3 of all the way around the circle, and so the circumference, the length of the minor arc is 1/3 of the entire circumference, so it's 1/3 of 96, which is what you wrote.
That's right, Seth. But let me venture to say that at no more than 1/3 of the people doing this question would know this relation.
Well, it was practiced. I think I recall using it a lot and reviewing it a lot during my was it 10th grade geometry course.
Yeah.
So it's one element of common knowledge about angles and circles. I could give you I could give you a proof of it that uses other properties of triangles.
No, we did it here, Seth. The proof is here. I did it here.
Well, I have a better proof.
Well, hold on 1 second. So let's people can go before that proof. So first of all,
that proof is excessively complicated.
Yeah, so maybe we won't do it at all.
And it relied upon you remembering that fact about half of the difference, which is something I didn't have in my memory as a fact.
Right. So let's very basically.
So the two of us remembered a different set of facts from geometry.
I have a geometry cheat sheet for circles. If anyone, by the way, wants my geometry cheat sheet for circles, which lists the 15 or so circle theorems that you need to know, you can email us at SATmathquestionoftheday@gmail.com. Request the circles cheat sheet, and I can send you my Churchill cheat sheet, which shows all the theorems. Guess what? This theorem is not on there. I should put it on. But really what it is, it's really a consequence of this theorem. So the way my attitude is that why have to, it's nice knowing this, but it's more powerful to remember the theorem that if you have a circle and you have like this, two secants, and this is A and this is B, and this is angle theta, right? Theta is equal to 1/2 A minus B.
Oh, yeah.
Okay,
it's a cool theorem.
And therefore, the same thing goes with tangents. If this is A and this is B, right? It's the same thing. Now this is B minus A. I'm really driving everyone crazy.
Yeah.
This is A minus B, and this is theta. But in practice,
cool.
if you ever have this problem, the A and B are related, right? Because A plus B is equal to 360. So then, if you know these two things, what Seth just said comes out of that. And my attitude is that why bother your brain remembering an extra theorem when you can remember the more powerful one? See, this one here is more powerful because you can do more problems.
Well, unfortunately, I did not remember the more powerful one.
Fascinating. You remembered the one that had the consequence of that. Interesting. So that's where we come from. We remember each different theorems. Going into the SAT, you probably should know the 15 or so circle theorems. They don't know. Sometimes they never ask a circle problem. Actually, they usually do ask a circle question, but you don't know which one. This was a particularly hard one because you had to know either the thing Seth knew or you had to know the thing I knew. So it makes sense to know the 20 or so circle theorems.
Yeah. Okay.
And
let me show you let me show you a demonstration that demonstrates it without the use of the circle theorem that Joel quoted.
Okay, sure.
So some people might figure it out this way.
Wait. But if you want it, I think we've done enough for many people. So if you want to go, goodbye. Have a good day, Seth. We're going to continue talking. I'd like to hear what Seth has to say about this.
Yeah. Okay.
Go for it.
Okay. So I need some space.
Yeah. Well, How about this? How about giving you this piece of real estate? Is that enough?
I don't see it.
Okay, wait.
That piece? Yeah, close enough.
There,
all right, here
go.
we go.
Okay, go.
So here's the situation. Do it in red. Okay. So what do we have? We have a circle, and we have two tangents through a common point, right?
Okay.
And we draw. I twiddled it, and then it decided. Okay, here we go. And then we have the center of the circle.
Oh, I know what that's
we draw. Hold on. We have these radii.
I know what that's going to do.
And a fact that Joel quoted is that these even though they're not drawn to look that way, these are right angles. Okay, now by symmetry, if we connect these lines by symmetry, these two angles are equal. These two angles are equal.
Yeah.
And what happens?
That's a smart way of doing it.
Yeah, what happens?
That is a smart way.
Yeah. And so I want to show that, okay, and these are right triangles.
Oh, yeah.
These are right triangles.
Right.
And so this angle is the complement of this angle.
That's right.
And so the total angle, well, let's see, why does it prove that?
Seth, it's 60. Each one is 60,
no,
so each one is 30. This is 30.
No, in general, I want to show.
Oh, in general. Okay.
I want to show that this angle is twice this angle.
Okay, Seth, can I just take a quick break?
And is this true?
Seth.
Okay.
Wait. Can I just talk for maybe? Give me 20 seconds. Give me 20 seconds. Okay. Seth
maybe I'm wrong here.
Wait. But
okay.
Seth, wait. Seth is really smart. Seth came up with another way to do it, which is really smart.
I don't know.
Seth, give me 20 seconds. Seth,
in the case of 30,
Seth,
in the case of 30, it works.
Yeah, so that's right. What you could do is you could put a 30 there. These are right triangles. This is a 60. This is a 60. Or instantly, it's 120. Third of a circle, you're done with the problem. Yeah, Brilliant job, Seth. Good job noticing those are congruent right triangles. One is 30, the other side 60. Let's give it for Seth. Let's give it for Seth. That is a brilliant way of doing it. You don't have to remember any of these stupid circle theorems.
Right.
Good job, Seth. Good job. I hope people stayed on for that. Anyway, now you want to see if it's true in general? I don't know.
Oh, is it true in general?
Doesn't look like I don't know. Well, we know it is because you can prove it this way. So, but this is theta, and this is 90 minus theta. So that's 2 theta, and that's 180 minus 2 theta.
Which doesn't say that. It doesn't say that 2 times 180 minus 2 theta.
This here is always 180 minus 2 theta. And is that correct? That doesn't seem right. That doesn't seem right because in our example,
is theta the little angle? Is theta the little angle? Let me talk. Is theta the little angle?
Yeah, theta's the little angle. Yeah, theta's the little angle.
I think this needs to go back to the drawing board.
No, theta's the little angle. Theta in this case is 30. So this is correct. Yeah, so that's the theorem.
Okay. I think I need to take this offline. I'm not. I think about this a bit more. Play with it some more.
Oh,
okay.
Wait, are you saying that your little theorem is wrong?
It might be.
That's embarrassing. That's embarrassing. Yeah. You know, me, you're right. You may actually be wrong.
No, I'm wrong.
Really? You're wrong.
I'm wrong.
You just have to be lucky that in this case, with the friendly 30, 60, 90 triangle, they dug you out. Ooh,
so the property that the oh gosh,
that is a crash. So that's
really that is a crash. I used a false theory. I used a false fact.
Oh my God!
Mistake. Yeah, this property. This property is true. It's required that the given angle was 60 degrees. Yeah.
Oh,
so
God.
here's how I realized that the theorem I thought was I had a false recollection.
Oh, this is not.
Let me show you how I realized I was wrong.
This is not good.
Not good.
No, what's really bad about this is that some people watch this video, and they may have turned off the video.
Well, that's too bad. They shouldn't have turned it off.
Well, we're gonna have to say correct for the next 5 days. We're gonna have to tell people go back to November 8th's video because the theorem Seth said was wrong.
Okay.
Okay, because we.
So here we go. So the story is, well, I need space. Come on, give me some space.
Okay, there. Here, go ahead.
Okay, here we go. So consider the limiting case where, here we go, we have a circle. Yeah. No, here we go. Here's our circle. And we have two tangents that go off
let's give you some more space.
Into Never Land. Go way off. We're far away, right? And this is a tiny angle.
Right.
That's a tiny angle.
Right.
And then we draw the two radii. And this angle here.
Yeah, there's no way.
Is a little bit less than 180.
So it's no way it's true.
There's no way that 180 is twice a tiny angle.
Wow.
Okay. So really you do need
oh, I feel bad for you.
You do need what the theorem that Joel quoted, which was what? That you have. Oh, come on.
I know it's very frustrating.
You know, what is it that yeah. You have the A and the B, right?
Yep.
A and B, and what was it? B minus A over 2. Right. B minus A over 2. So B is the angle around here.
Yep.
And A is the angle around here.
Right.
B minus A over 2 equals theta.
Right, and then there's a relationship between B. B is equal to B plus A equal 360.
Yeah.
I just like to do the plus thing because with the minus thing I get confused which one is the minus, which one is the minus, and which one is the plus.
Yeah.
But it will be B minus A because B is bigger than A.
So let's see what's the constant was. B.
Well, it's to get the same formula. You always get the same formula.
Hold on a second. So B equals A minus 360. B equals 360 minus A. We can't escape that. Yeah. So what is it?
Yeah,
B equals 360 minus A. So we have 360 minus A equals B minus A.
Yeah, so 360 minus
divided
2A.
by 2.
Right.
And let me simplify that. That's 180 minus 2a plus 180 minus...
No, 2a, but divided by 2.
Yeah, it's minus 180 minus a equals theta.
Equals the big angle theta. Yeah.
Equals theta. So a theta. And so what is it? A equals...
Oh, wow. A is supplementary to that
So
angle.
what we have is the theorem is that theta plus a equals 180 degrees.
The supplementary. Theta plus the angle.
Okay. All right, so now I could prove that.
Yeah.
I could prove that.
Right, I know.
Hold on.
Okay, sorry.
Here's the line here. And so we have half of theta is complementary to half of a.
Right.
And so theta is supplementary to a.
Right.
Which we wrote here, the consequence. We demonstrated that from b minus a over 2 equals theta, but what we could do is use these congruent triangles to show that theta and a are supplementary, and from them being supplementary, we could derive that 360 minus a over 2 equals theta.
Right.
Okay.
The bottom line
from the use of congruent triangles to prove that theta and a are supplementary. So theta and a are supplementary is pretty directly provable to be equivalent to b minus a over 2 equals theta. Okay.
Right, but no one's ever going to do that. Look, they're the way Seth at first, his theory was wrong. So there are really only two practical ways to do the question. One of them is to do the sort of the traditional angle, not traditional.
Yeah.
The one using the theorem about the angle here is half of the difference of the subtended arcs. But actually, the way Seth did it, I really like the triangle one. I really like the way way this is done with the right angle. Yeah. Notice that I alluded to that when we first did it. I should have realized that this is 30, this is 60, this is 60, this is 120. Third of a circle, 96 divided by 3 is the answer. This is
if they had a different problem, if they had the 60-degree angle, say being a 50-degree angle, then this triangle analysis would lead you to the answer.
Of course. The triangle analysis is correct.
Yeah.
It'll always lead you to the answer. I like this because
to the answer to this problem.
Well, yeah, obviously. Yeah. But I like this one over the way I did it. But people may not, but you have a choice, right? You have a choice. Which one do you remember? But it is very helpful to know that the tangents to a point, oh, boy, that's a real messy drawing. The tangents to a point are the same. Yeah, remember that? They are the same. They are the same. Remember that? And as I always say, all radii are equal, right? And this is a right angle. So knowing those basic things you really should know about circles going into the SAT, you could figure this out without remembering that theorem about the half angle, the angle being half.
Yeah. So it helps to look for, to try to detect congruent triangles.
Not only just congruent triangles.
Now, what leads me to look for congruent triangles is the very symmetry of the situation.
Right.
We look at I'll show them the original diagram again.
Okay.
Shift it around to show them the original diagram. And we see in the original diagram that it's symmetrical. around the horizontal line. There's a line of symmetry. I'll use red. There's a line of symmetry from here to here, and so it draws you to realizing that the line from O to M is interesting.
Yeah.
And indeed, once you draw the line from O to M, by symmetry, the triangle above the triangle above that line and the triangle below that line are congruent.
Right. So yeah. That's what's nice about circles. So now I'm going to give off the thing I always say, which helps you more than it doesn't help you. It really, really helps a lot in geometry problems. First, let me kill that annoying cell phone. When in doubt in a geometry problem, draw perpendiculars and all radii are equal. Really, trust me, look for that in a geometry problem. And then when really in trouble, look for similar triangles. If you see a geometry problem that you can't do, look for similar triangles. But seriously, when in doubt, drop perpendiculars and all radii are equal. Dropping perpendiculars is great because it forms right triangles. Now, you can notice that if you sort of thought about this in this problem, it would have helped you. Drop perpendiculars, well then when you drop perpendiculars, you want to look for right triangles and all radii are equal. You needed that to prove the symmetry, to prove the fact that those two triangles are congruent. So anyway, just keep this in mind when you have a geometry problem. When in doubt, if you're stuck in a geometry problem, drop perpendiculars and all radii are equal. Sometimes you forget all radii are equal. When you're really in trouble, look for similar triangles. Similar triangles doesn't apply here, but anyway, words of wisdom. Attempt at a words of wisdom from experience. So what do you think? You think we're done?
Yeah.
Yeah, and of course with circles, Seth said look for symmetry. Wow. Okay. I'm sorry, Seth, wow, you really... really, the worst thing to do is to give a wrong formula to our listeners. So we'll have to make corrections to that. But it happens. We'll have to make corrections for the next 5 days. We'll tell people to go back and.
Yeah. So maybe we could just delete this and do a new one.
We can't. No. We have to have all my mistakes go through.
It's against the rule.
It's sort of. There would have to be an extreme example for us to not show a video that we make. I mean, it would have to be so off the chart, horrible, and no. This has to stay because we make mistakes, and we all make mistakes. But Seth really made a mistake there, using the wrong formula. Okay. So anyway, we'll put corrections in for the next 5 days. For the next week, we'll say, hey, if you watch the one on November 8th, I mean, you know what I'll do? I'll also put something in the description saying, warning, the formula that's at the beginning of this video is wrong, okay? Watch the whole video to make sure. Okay, I'll put that in the warning of the video. That'll also help. Yeah, I'll put that in the title of the video. Warning, one of the formulas in this video is wrong. Watch it to see which one.
Well, what you could do is mark the timestamp.
Right. Yes, I will. I'll mark it. Okay. So this video will live in forever perpetuity. So hopefully you're not going to be up for a job promotion. So watch this. Are you kidding me? But I also made a lot of mistakes too. So we all make mistakes. Okay, everyone, have a great day. And of course,
but the moral of the story is that when we connected a lot of things together, when you consider many things together and check everything with itself, everything against everything else, mistakes can be tolerated. Because you'll discover them, or you will apply a logic that doesn't follow from the mistake.
Right, but the thing is, when you're not taking an SAT, you have that luxury. If you are taking the SAT, you don't have that luxury. And by the way, Seth, this also explains why this theorem is not on my circle cheat sheet. It's not true. It's not true. That's why.
Yeah,
it's not
but I guess that theorem is theta equals a half of B minus A. Is that on your sheet?
Of course it is. Of course it is. And it's in different forms. It's not it's in the secant form. Sorry. It's in the secant form. Oh. It's in the tangent form. It's in the one tangent and secant form. It comes in 3 different ways. 2 tangents, 2 secants, 1 tangent, 1 secant. Of course it is. Okay.
Yeah.
Okay, good. Everyone, like us, dislike us. I can see why you'd want to give us some, not like this one. But maybe you do, because we're honest here. And then, of course, send us your questions at satmathquestion@gmail.com. Okay, everyone. Bye-bye.
Yeah. Bye-bye.
Bye-bye.